Hey everyone, and welcome back to No Code Nest. Today, we're diving deep into the exciting world of AI, and specifically, we're going to explore the capabilities of DeepSeek. We'll start by seeing how easily you can discover and access information about its latest advancements, like DeepSeek V3.1. Our journey begins as we navigate through a Google search for DeepSeek V3, quickly leading us to a wealth of resources. We'll land on the official DeepSeek V3.1 release page, where key details about API updates, upgraded tools and agents, and pricing adjustments are laid out. You'll see a benchmark performance chart that puts DeepSeek V3 head-to-head with its competitors, giving us a clear picture of its strengths. The exploration doesn't stop there. We'll then move on to a technical report on Archive, which offers a comprehensive deep dive into the architecture, pre-training, and post-training phases of DeepSeek V3. This initial phase sets the stage, showing us how accessible cutting-edge AI research is becoming. As we continue our exploration of the DeepSeek V3 technical report on Archive, we'll find ourselves meticulously navigating through its detailed table of contents. We'll delve into sections like the abstract, introduction, architecture, and the crucial pre-training and post-training methodologies. A particularly insightful part is the benchmark performance bar chart, allowing for direct comparisons between DeepSeek V3 and other prominent AI models. We'll also observe links to vital platforms like GitHub, OpenRouter, and Hugging Face, where we can find more about the DeepSeek V3 model, its activity, and download options. The Hugging Face page itself provides a wealth of information, showcasing the model's usage and potential. This segment really highlights the transparency and community-driven aspect of AI development, with detailed evaluation results for DeepSeek V3 presented alongside its peers across various benchmarks. It's fascinating to see the meticulous documentation and accessibility. Now, let's shift our focus to a broader overview of DeepSeek V3.1 as we browse through a website packed with valuable information. Here, we'll see a clear table comparing benchmarks and performance metrics across different versions of DeepSeek, giving us a tangible sense of its evolution and improvement. The site details its features and technical innovations, really underscoring the advancements made. What's particularly interesting is the cost-effectiveness comparison, placing DeepSeek against well-known models like Claude Opus and GPT-4, which offers a practical perspective for users. We'll also witness navigation to a dedicated documentation page for DeepSeek, providing further insights into its functionalities, and then circle back to a Google search results page specifically for DeepSeek V3.1, demonstrating the interconnectedness of information discovery. This part of our journey really emphasizes how No Code Nest helps you understand the practical benefits and comparisons of these powerful AI tools. The next part of our exploration takes us directly into the DeepSeek AI platform itself. We'll witness a user interacting with the DeepSeek API documentation, specifically focusing on release notes and pricing details for DeepSeek V3.1. The video will highlight key improvements in V3.1, such as enhanced performance on SWE bench, stronger multi-step reasoning capabilities, and increased thinking efficiency, all visualized through performance metric tables across different versions and benchmarks. Then, we'll see the user attempting to access the DeepSeek chat feature, leading to a login page. Here, they'll have choices: login via email, Google, or a phone number. The user opts for a Google sign-in, initiating a verification process. Finally, we'll be presented with the DeepSeek chat interface, ready for interaction, showing a welcoming "Hi, I'm DeepSeek," and options to start new or use existing chats, along with Deep Think and search functionalities. This is where things get incredibly exciting as we witness DeepSeek's remarkable ability to handle complex, multifaceted prompts. The AI is tasked with a series of challenging requests. First, analyzing an algorithm's time complexity and proposing an optimization. Then, it shifts gears to synthesize insights into a philosophical essay exploring whether machines can truly understand metaphors, referencing cognitive science, and offering its own translations. We'll see a fictional passage presented for analysis, which DeepSeek will interpret, extract hidden metaphors, and map them to scientific concepts. The AI will also translate this passage into Japanese and Arabic, meticulously preserving and annotating the metaphors. Following this, DeepSeek is asked to generate a Python algorithm for creating similar metaphorical passages, and then revisit the time complexity analysis. The demonstration continues with the philosophical essay, and finally, a completely new challenge, acting as an expert game developer to write a complete HTML file for a functional 2D top-down car racing game. And that game development task is precisely what we'll see unfold next. The user provides DeepSeek with a detailed prompt for a 2D top-down car racing game, specifying requirements like realistic car physics, AI opponents, checkpoints, lap timing, a HUD, skid marks, sound effects, and even a day and night mode. DeepSeek's response begins by outlining the structure of the HTML file, including basic HTML, CSS styling, and JavaScript functionality, listing all the key components that will be implemented. We then witness DeepSeek generating the HTML, CSS, and JavaScript code in stages, with both the user and the AI progressing through the implementation. Crucially, towards the end, a preview of the top-down racer game is shown. This demonstrates that the generated code has been executed and the game is running within the browser, featuring simple graphics, 2 cars, a speed indicator, and lap and position information. It's a fantastic showcase of AI's capability in creating functional web applications from scratch. Now, let's experience the game that was just brought to life by AI. What you're seeing is a top-down racing game, a creation entirely generated by AI, featuring realistic physics, a day and night mode toggle, skid marks, and sound effects. The gameplay showcases the player expertly controlling a car, racing against an AI opponent on a challenging track. You can see the player actively drifting around corners and accelerating, demonstrating the game's responsive controls. At one point, the player demonstrates the day and night mode toggle, seamlessly switching the environment. The gameplay continues, highlighting how the player navigates the track while the AI opponent intelligently follows its programmed path. This is a perfect example of how AI can bridge the gap between concept and a playable experience, all through code generation. Now, let's experience the game that was just brought to life by AI. What you're seeing is a top-down racing game, a creation entirely generated by AI, featuring realistic physics, a day and night mode toggle, skid marks, and sound effects. The gameplay showcases the player expertly controlling a car, racing against an AI opponent on a challenging track. You can see the player actively drifting around corners and accelerating, demonstrating the game's responsive controls. At one point, the player demonstrates the day and night mode toggle, seamlessly switching the environment. The gameplay continues, highlighting how the player navigates the track while the AI opponent intelligently follows its programmed path. This is a perfect